So I get to make the claim of having the awesome talk. Okay, so my Twitter hashtag is at Raymond H, so tweet away. I will look at some point. If you want to pass some questions along on Twitter, I will take a look before the end. We'll scan through them and answer them. As Richard pointed out, I'm trying to use Twitter in a different way. I'm trying to send out technical tweets, so I challenge myself every day or two to try and put together something technical and useful and to fit it into 140 characters so that I don't waste your time. And today's talk is what makes Python awesome? You wouldn't be here if you didn't think that Python was an awesome language. But then I have to raise the question, why is it awesome? And what I did was went around to a number of companies. I can do a lot of consulting and training, and I've talked to a lot of people and tried to collect some survey results back and share what are the characteristics of a truly awesome language. So, quick introduction here. I'm a PSF board member. I've been a core developer since 2001. I put together a lot of tools that you use every day, like I wrote the set objects and iter tools and lots of other interesting gizmos, one of the latest being the LRU cache and the new chain map function. And there's my Twitter account again. All right. Name an awesome language. Really? Why?
I can read it.
Readability?
I can reread. I can read somebody else's.
I can read somebody else's code? All right, something makes it great. Let's see if we can figure it out, because there are other awesome languages. I contend that all of these languages are awesome. I have programmed in all of them at one time or another. I've done very little programming in Lua and Scala, but most of these others I've used heavily at one time or another. And if you have heard of them, that means that they're awesome, because there are thousands and thousands of languages out there. If it's gotten to the point where you've heard of it, it meant that at one point in our history, it solved a problem well, a problem that people had, and it overcame them. How does Python get itself on this list of awesome languages? What makes it special? Why did I stop programming in awk and assembler and Lisp and come to Python? It had something that made it better. What was that stuff? So I had many languages to choose from. Lots are good in their own way. Our goal is to identify the success factors. All right, so I'm going to start from a very high-level contextual point of view. If we're going to make a new awesome language, let's set a good context for it and get the context factors right. Then we're going to go in one level and say, once we've got the context, what are the actual characteristics of the language that we want? Because there's lots of little design choices you can make of just the overall layout of a language. And then having done that, we will go into the specifics of what is it that Python has that other languages don't. So one of the context factors, one I think is vital, is our license. So an open source license, at the time Guido made Python, lots of people were creating languages. He put his out on the net and let other people contribute to it, and he made it open source. That changed everything. When I go into some companies now, they are choosing between Python and languages that require a license where they have to, for every person who runs an interpreter, they would have to buy a unique license. Python is free for them. That's fantastic. Being free and being open source is a fantastic thing. I tell big companies, what is the advantage of open source for you? The advantage is if everyone else quit using Python tomorrow and went on to next cool language X, would your company be left in a lurch? No, you can recompile Python yourself and add on to it and modify it. You are not trapped as you would be with another tool where you don't get the source code behind it. I think this was vital. So if we're going to create a new language, we need a good open source license. It is vital, I think, for a language not just to be open source, but to have commercial distributions. We have ActiveState and InThought selling Python. Why would you buy Python if Python is available for free? The answer is there's some value adds that these companies put in. They roll together other things in their distribution, like the InThought distribution includes tool sets like NumPy and SciPy and lots of things precompiled. They've made it easy to install on your machines in a consistent way, regardless of your platform. They provide phone support. Many big companies, what are they looking for when they buy something? Why would they pay for something they can get for free? They want a throat to choke, somebody to say, this thing isn't working, fix it now. And so these guys will fix some critical bugs for those companies, and they contribute back to the community. I think having a commercial side is vital, and if we had had a license that prohibited the commercial side, we would have lost this. This is an enormous benefit from us. It is why really big companies can adopt Python. And we've got Zen. Now, all of you went to Richard's talk yesterday, probably had a mind-opening experience of what the Zen was all about. I've thought I internalized Zen the very first time I read it. It was only after listening to Richard's talk that I realized there was a lot more to it than I had ever thought about before. But what is the significance of the Zen from a contextual point of view? All of the core developers read this. They try and internalize it to some degree, and we try and program in that way. And so it makes the language much more uniform and consistent than a language that doesn't have a shared core philosophy. It almost doesn't matter what this philosophy is. If you're going to make a new language, you want to create a philosophy so that all the developers are all marching in the same line and make pieces that fit together really well. I think Python has done a magnificent job for us, and the Zen was part of it. It is part of what makes the language so easy to learn, and once you've adopted this mindset, you know what to expect out of the language. I think it's fantastic. There are other types of Zen for other languages. Perl values the many ways to do it, and I don't think that is a wrong answer. For them, you can always choose the very best matching tool out of many. That is their philosophy, and they stick with it fairly well, and it has been a winning strategy for us. We choose the one way to do it. It's our philosophy, and it's worked well for us. It almost doesn't matter what the philosophy is. You need unifying principles when you create a new language. More Zen. I think a killer feature for a language is to have community. It's fantastic that you can go out to Complang Python news groups on Usenet and ask a question. Wow, there are lots of XML packages out there. Here is my particular need and use case. Can you guys tell me which one is the best? And experts will chime back in and say, LXML is the fastest for your particular need because of your volume. Or you need ease of installation, so you want to use things that are already in the standard library. We recommend the element tree package, for example. This is a fantastic resource. There are plenty of other languages that are used in companies all over the world where the people programming, they can try and look something up in a book, they can try and do a little research on the net. There's no place they can go and just ask questions and get answers from core developers or other senior developers all around the world. The community is a fantastic reason for adopting Python. We have a mailing list, the Python dev mail list. There's Python help, where you can get individual help. How many of you knew about Python help? Oh, fantastic. Interesting thing about Python help is that the kind of people who are in this room, a lot of you will become top-level Python experts in a short period of time. You can go on the other side of the help desk and volunteer to help man it and answer questions from people all around the world and give them individual help, and they really value that. It's something our language offers that I think very few other languages have, and we have a tutor list. There are PyCons showing up everywhere. I've heard there's one as far away as Australia. And this little island nearby, New Zealand? Yes, okay. Actually, from your point of view, those things are close, but they're popping up all over the world, and it's fantastic. And there's Python interest groups everywhere. I consider these to be contextual factors for the success of a language. We're going to build some language. We need a good, rock-solid community. We need a good license. We need commercial support. But also we need a way to exchange packages. And for us, I've heard this pronounced in many ways. One of my favorite is Pippy. So Pippy is the repository of packages. We're up in the 16,000 range right now, and it's fantastic. They're free. You can, often when you go to solve a problem, you can do a search of Pippy and find that someone else has already solved it. If you use pip, you can install it very quickly by saying pip install order Dict, and presto, in Python 2.5, you can have an order Dict because the code has been backported. I think that's fantastic. Very simple installation procedure. Who thinks that's wonderful? It rocks. Okay. And then every language to get on the map has to have a few killer apps and success stories. Why is Zope up here? Zope was the first, biggest, and best in its time. we should all thank Zope, because we wouldn't be here right now if it weren't for the success of Zope. There are later successors, such as Django and Pylons, other web development frameworks. There's an enormous scientific community, which would not be there if it weren't for Matplotlib, SciPy, and NumPy. BitTorrent was written in pure Python, and so it's a wonderful success story. It was put together in very few days. And if you are into reading technical papers, the technical description of how BitTorrent was put together and why its design decisions made is really a wonderful paper. It's about an hour-long read, and it will make you smarter. And at one time, BitTorrent accounted for 50% of the traffic on the internet, written in pure Python. Twisted is a major success story. YouTube was a pure Python shop. Even now, they are 99% pure Python. I was talking to Friedrich Lund. He's one of the chief architects at YouTube and a Python core contributor. And he said, if Google were to fall over dead tomorrow, the largest search engine in the world would be YouTube. They upload 15 hours of video every second. It's really fantastic, all written in pure Python. Blender has incorporated Python as its embedded scripting language. I have to remind people get so used to using, just starting up a Python interpreter and typing away and making a Python program, they actually forget that you can do things the other way around. You can take some giant C application, then embed Python inside it, and presto, that language has a scripting language embedded inside it. So let's say you had a big product, giant spreadsheet, you've distributed all over the world, you've got a custom file format called XLS or XLSW or something like that, and you need a scripting language for it. You could adopt Visual Basic, or you could embed Python inside, and presto, Python would be the scripting language for Excel. They could put that in overnight. I think it's a fantastic thing. And then Win32. A lot of you in here are Linux users and Mac users, and so we tend to forget that 90% of the computers in the world are running Windows, but thanks to the efforts of Mark Hammond and the Win32.com, almost every service that's available on Windows is accessible through Python, and that's a wonderful thing. And Microsoft does some things incredibly well, like the COM interface is just magical. Because of COM interface, one of my very first Python programs that took me only a few minutes to write was I'd link to the object model for Excel. I could access it as if it were native to Python. I didn't have to do any DLL links. And so I grabbed some stock symbols off of a spreadsheet, went out to Yahoo, looked up their prices, and then repopulated it back into the spreadsheet and computed my enormous wealth for the day. And from Excel's point of view, all I had to do was press a button that launched the macro. I think that's fantastic. How did those things get linked together? Did I have to use C types or anything? No, the COM interface was fast and clean, and pretty much every tool that's available in Windows has some form of COM access so that you can drive it from Excel. And I think that's wonderful. And then we've got books. Why are books important? Well, most of you, who's bought a Python book before? Okay. I think it was essential to your learning to have some books available. A language I really like is OCaml. OCaml has no books. And has made it frighteningly difficult to learn well and to get different perspectives on. I've had a couple technical documents I could read to learn more about OCaml, but really you're left twisting in the wind. I think having good books is essential context for a language. So the summary of a context is, I think in order to get a language up and running and make it awesome, it has to have an open source license. It needs commercial backing. It needs Zen or some unifying philosophy. If it has a wonderful, inviting community like you guys here, that will contribute to success. We need a way of exchanging work, an enormous body of free resources available. We need a few killer apps and success stories. We need to access the 90% of the computers in the world that run Windows, and we need a few books. Those are the contexts for success. That makes it possible for Python to be awesome. If you've done all of those things, your new language X is on track. Now, you've got a new language X, you've got all of these features. Now you need to decide what characteristics are you going to adopt in your language. Is it going to be low level? Is it going to be high level? How is it going to allocate memory and that sort of thing? Let's look and see what choices this Python language made. What qualities of the language itself make it awesome? I think one of its most endearing and wonderful qualities is its ease of learning. Those of you who attended Peter's class yesterday just had a wonderful learning experience. His wonderful teaching styles, delightful to listen to, but think of how much you learned in 3 hours. In 3 hours, a person can learn all of the internal types, lists, sets, dicts, tuples, floats, stir, knit. You can learn the control flow structures, while loops, for loops, try, except, if, then, else. And then you can learn the basic organization tools for aggregating those statements of functions, classes, and modules. That's possible to learn in 3 hours. In a day, I can go forward in one of my classes. I'll make sure that you know by the end of the day some common Python idioms, the methods on the most common objects, and give you a tour of the library and show off the special methods. That can be taught in 1 day. That's fantastic. So a problem that we don't have now that existed about a decade ago, so I've talked to companies, they said, we're concerned about adopting Python as our language internally because we don't know where we'd go to get Python programmers. They would look through job listings, and very few people listed Python as one of their background skill sets. And they said, we don't think we'll be able to get Python programmers. And I had to change their mindset a little bit, and I said, if you need good C++ programmers, how long does it take to grow one from scratch? Well, they can take a course, then read a couple books on it, and then start practicing it, and after 2 years, you can have a pretty good C++ programmer. Or you could adopt Java, and they could read a book, take a couple seminars, start practicing it, and after 6 months, you can have a pretty decent Java programmer. But if you give me someone who already knows how to program in any language, in a week, I will give you a Python programmer. I said, you've already got them. There should be no fear of adoption. Now, lots of people now list Python on their resumes, and companies are less concerned about, can I find Python programmers? But I still have to remind them of the selling point is, if you've got programmers already who are smart and know your problem domain, I can turn them into Python programmers in a week. I can turn them into really good Python programmers in 2 weeks. And I think that's fantastic. That is hard to do with a number of other languages. And I think it's one of the things that makes Python awesome. You guys like that part? Fantastic. All right, the rapid development cycle. When I asked you before, what makes Python awesome? No one mentioned that. This is fantastic. Scripting languages are unbeatable for their speed of development. My first scripting language was awk. I loved C at the time. I programmed lots of C. I believed in the book called Born to Code in C. I thought C was the most wonderful thing under the sun because I could do anything with it. It was structured, portable assembly language. And then I encountered awk. And my productivity went up by a factor of 10. I've done weird things with awk. I wrote a flight simulator in awk, for example. And I've heard this interesting notion, I've forgotten the phrase for it. It had to do with the distance between the thinking of the thought and the formation of the code. And with awk, that distance closed quite a bit. As fast as I could think thoughts, my flight simulator should be able to compute these turns, take into account the weight of the aircraft, the wind. As fast as I could think those thoughts, they would drip out of my fingers onto the page, and I would have working code. I loved awk. The problem was, awk didn't have libraries. It didn't have internet access, it wasn't object-oriented, and it didn't have concurrency, things that I needed. So I started looking for another language. Python provided that, and yet it also provided the ability to type fast, get code up and running quickly, and the speed of development. It is hard for me to convince people in big companies. I will go in and tell them. I give them some sample problems and say, here are some tasks. How long would it take your team to, in Java or C++, write this code and get it tested? And I can present them with a challenge, like, well, this will take a week, or this will take a day and a half. And I'll sit down and bang out the code for them in about 10 minutes, 15 minutes. The order of magnitude difference in productivity is just enormous, how quickly you can get good code up and running. The interactive testing lets people work with their tools up. The organic growing style means that right at the beginning you get something up and running, and then you continually add to it so that at any given time someone can walk in and see your running program and say, here's what it currently does so far. And if you're practicing test-driven development, you can say, I've implemented these features. These features are fully tested, and if you're using doc strings and run it through PyDoc, I already documented everything I've done as I was growing it real time. And if you use tools like Sphinx, you can combine all of those together and make nice, beautiful documentation as fast as you develop. I think that's wonderful. Who thinks that rocks? All right. And then for people coming from compiled languages, it's hard for them to realize how much more productive they get with that interactive prompt. Okay, so this is a favorite example for me. It came out of, I taught one of David Beasley's courses at one point, and he had this practicum exercise that I thought was wonderful, and I no longer let students solve it. I solve them for it. I solve it for them, and what I like about this is there is a problem description that reads something like this. We need to make some counts of URLs of, I'm going to have some log files that are spit out by Apache, so I have a month's worth of log files. I keep those in a data logs directory, and they're all gzipped up. And I need you to go into these Apache log files, pull them all up, and they will list out all of the resource requests. Get this resource, we'll get another resource, and as Apache serves them up. I need you to scan those files, find all of the GET requests, find the URL, the resource that was requested, and count them all up, and then determine what are the 20 most common resource requests. It took me almost 3 minutes to say the problem description. It didn't take much longer to write the code for it, and what I particularly like is not only how short this program is, but also how it corresponds directly to the business logic so that I can explain to somebody who is not a Python programmer what it does. I'll tell them, this first line opens a counter. It's a thing for counting. It corresponds to the problem description of where we say, get ready to count something. I say, let's loop over all of the files in the data logs directory that end with GZ. It took me more words to say that in English than it took to say it precisely in Python. Let's loop over all the file names in the data logs directory that end with GZ. That's fantastic. Next line says, for line and gzip open file name. Okay, for line and file name, that's not an impressive. Well, that takes me a few more lines to do that in C, and that takes care of the automatic, the universal new line handling, the whole 9 yards. Oh, look at this, that gzip.open. That's wonderful. That meant that I didn't have to go unzip the files before I read them. We can read them directly. gzip.open makes it transparent for us that it was actually gzipped. I think that's fantastic. So it takes many fewer words to say it in Python than in English, because in English we would say, all right, for each of those files, go in and unzip them, now loop over them line by line after having parsed the line endings, take those line ends, and then for each one, iterate over them. Many words to say it in English, much clearer in Python. The next line says, search that line for the word get and HTTP, and take the characters in between those two and group them. The parentheses being the grouping symbol for a regular expression. If I've got a match, let's call that group the URL. So the URL is the thing after the word get and before the word HTTP on the lines in the Apache log files. Now that I've got a URL, count it. The counts plus equal 1. I can show this logic to someone who is not a programmer, and they can be pretty confident that it matches the problem description. And then I can say use keep few and give me the 20 largest counts. Now I'll call up pprint and print it out in a beautiful fashion so that we have a nice table that says the atom.xml feed was the most popular hit, followed by favicon, followed by David Beasley's ply package. I think that's fantastic. This is not an atypical task for a sysadmin. I bang this code like this out fresh in a class. I have a whole little set of problems where I will just bring up something and say, choose a problem, and I'll just there and code it from scratch. And it takes me 5 minutes to knock out code like this. And as I'm going, when I type in these lines, this for file name in, as soon as I've written this line, I put here a print file name, and I run it. So I know those first 2 lines run. Okay, it successfully found the files. Then when I add this line in, I print the first line and break. Now I'm successfully finding the first line. And I showed them as I develop this code, I'm actually testing each line as I run it so that by the time I get to the end, I'm confident it does exactly what I expect. And that's fantastic because a Java or C++ programmer, someone who works in a compiled language, actually build the whole thing first then run it, and then when it didn't work, have to go into a painful debugging phase. Who thinks that's fantastic? It's got economy of expression. It's short. It was easy to develop. I could test as we go, and I can explain it to a non-programmer. I think that makes Python a fantastic language. Here's another example, just a little 5-minute script, and this was not a problem that I created. Someone in class came and said, well, I have an issue. I have an enormous hard drive, several terabytes of images. As a photographer who's done many has many directory levels and has copied files around to and fro and renamed them as he's done some image editing and whatnot. He says, I've got some duplicates and I'd like to find the duplicates. I said, well, he said, how would Python solve that? I said, well, very simply, we should make a mapping of some signature of the content to all file names that match that. The signature being, let's describe the image in some way that is unique so that if you've renamed the image, I can still tell it's the same image. So OS walk lets us loop down the directory tree, and for the Unix types, that's the equivalent of the Unix find built in. So I loop down all the directories, I loop over each file name in the directory, compute the full file name, so I have the path to get there. Why do I do that? Because sometimes you have the same file name under 2 or 3 different directories, and so this is more a requirement for the users of the output. They'd like to know, yes, I found duplicates. Well, where were they? Well, I should have remembered that. So we give them the full path. I open the file, read it, run it, compute a hex digest on it, and then build myself a mapping so that the signature maps to a list of file names. I just append each match. And then pre-print it, and I'm done. That was a 5-minute exercise. Bang, 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 bang. Let's run it over your directory tree. And how long does this take to run? Really depends on the size of your hard drive. You got several terabytes. It's not the Python program that's throwing you up. It's the speed limitation here would still be the same if this code had been written in C. All of the time is spent reading a file, running a hex digest on it. And we've heard Python is slow. What is it doing here? Open file name and read. How do those operations actually occur? Did Guido spend a lot of time writing the read built in? No, the operating system does it for us. So all Python is doing essentially is passing off to the operating system the read operation, meaning that is running at C speed. It is not running at Python speed. That is one line that says read a file, which hands off to the operating system that knows how to read a file. I think that's fantastic. We then take the file that we've read in and pass it to hex digest. Hex digest is written in C. This runs at C speed. This code would go no faster if you wrote this code in C. And then dictionary is the fastest thing in Python. Tim Peters is fond of saying, if you write some code in Python using dictionaries, it is a gazillion times faster than code written in any other language. What did he mean by that? He meant, if you're a C programmer, you know your computer's optimizing everything for you, so you tend to do a lot of linear searches because it's no fun to have to build your own hash map out of nothing. And so C programmers tend to do a lot of linear searches because it's a pain. They don't have dictionaries in their hip pocket. Well, we have an optimized data structure, a heavily optimized data structure, and I would contend that there are very few C programmers who could go toe-to-toe with Tim Peters. His TimSort algorithm is close to unbeatable. Has its own Wikipedia page now. It's been adopted by a number of other languages. They are modeling their implementations after Python because ours is the most efficient. Who thinks that's fantastic? This code is fast. It took me minutes to develop. It was reliable, and the only limitation on the speed was really it was an I/O-bound process. Beauty counts. Readability is the #1 most mentioned characteristic when I go out and say, why do you like Python? Why does that matter? Well, one reason it matters is it affects your relationship with the computer as you type all day long. I enjoyed APL. I thought APL was an amazing language. I still think it's an amazing language, and it inspired many other tools that followed or modeled off of APL. You can still see like remnants of it in the IterTools module in languages like Mathematica and Maple. But it wasn't beautiful, and so it wasn't joyous to program with. Python is one of those languages where I'm talking to somebody at a corporation and say, do your programmers go home from work and turn on their computer and write more programs? I'll bet they don't. And the reason is because their language isn't beautiful. Python is so beautiful that occasionally when I think of a new algorithm or something I want to play with, I just fire up an interpreter and write some programs. Are you being paid for this? No. Doing it for the joy of it. It's beautiful. Beauty counts. The other reason it counts is when most of our time programming is spent not in greenfield programming, but in maintaining other people's programs. And it's really nice to look at a beautiful program, to be able to go do updates to it. One thing I really don't enjoy doing is taking other people's C code and going in to maintain it. But other people's Python code I don't mind as much. The one way to do it is the number one mentioned advantage over Perl. It is just a different philosophy. They have a different style that works for them. Having one way to do it, why is that important? The answer is, in Perl, there are many different idioms you can use to solve a problem, and all of them are good in their own way. But if the person next to you is using a different set of idioms than you use, you will find his code to be impenetrable and hard to maintain. What's nice in Python is by having one way, preferably one way obvious way to do things, you can go look at someone else's code, and it tends to be readable to you. That's fantastic for me because I go into company after company doing consulting. I look at their code base. I make suggestions on how to improve its architecture and how they can improve their coding styles. And what's nice is I get to see how many different companies, how their code bases work. All these code bases are secret. I have to sign NDAs. But what I can tell you I see is their code looks remarkably the same from company to company to company. They have completely different problem domains, but their code looks the same. You can leave a genomics company and go to a high-frequency trading company and still know how to program in that company. You can't do that in some other languages where the styles are so different. That's why one way to do it matters. Our interactive prompt. One of the fantastic things about this is occasionally I get a chance to hang out with a really high-level Python program. So I get to hang out with Richard and Nick Coughlin and Guido, and when Tim used to come to the conferences, we'd go into the sprints together. Now these guys are deep Python experts. So if you went and asked them a Python question, would you expect them to know off the top of their head? No, Python programmers don't program that way. Python programmers don't memorize Python. All of these guys, if I'm in a discussion with Richard, he and I would sit down and fire up an interpreter, and we rediscover the language as we go. We sit there and Richard would teach me something new. Like yesterday, I learned that if you rename super in Python 3, it doesn't work anymore. I didn't know that previously. We rediscover the language. I think this is fantastic. In a compiled language, you can't do that. You actually have to memorize a substantial chunk of the language just to even write hello world in C. You have to know to do the include standard io.h and how to set up the main return void and whatnot, and this format for the printf, syntax formatting. A lot of that has to be memorized. You can type your code into Notepad. Then you run the compiler, and it tells you what you failed to memorize correctly. The interactive prompt is much more productive. And we have many interactive prompts. VPython and IPython are a different interactive prompt that accesses Python in a way that looks different, but it's the same under the hood. What's fantastic about IPython is there's a lot of scientists who don't have a need to write programs. They're doing data analysis, and so all of their interactions are interactive. They fire up IPython and say, load up this data set, summarize this data set, graph this data set, filter out these elements. Now run this graph on it. Now run a fast Fourier transform on it. Now graph that. It's an imperative style. They're telling the data how it wants to look differently and what they want done with the data. They don't actually care about the program. They care about the graphs that they generate and the data analysis they've done. I think that's fantastic. And Python is a batteries included language, which is really wonderful. One thing that shocks me when I go into corporate environments is, unlike your own environments where I can say, here, go download this. An amazing number of companies won't let people use USB keys, because there might be a virus on it. Can't download software. It's really important for them they have batteries included, otherwise they have to redevelop their batteries from scratch. Security will be the death of us. Okay, and then behind the scenes, we have a very conservative rate of growth. Our philosophy for core developers used to be, we read Nuth so that you don't have to. There are people like me who actually like to open up Knuth on the weekend and work my way through semi-numerical algorithms, and it's like reading mathematics, and there's people like me who enjoy it. And you get the benefit of it, and that's why decks run so fast. That's why sets run so fast. You get the benefit without having to read Knuth. And so we do complex and sophisticated algorithms behind the scenes, but we aim for a very simple, easy-to-use implementation. Sets have been highly optimized under the hood, but the learning curve for them is less than 5 minutes. I can teach you sets in 5 minutes or less. And segfaulting in Python is considered a critical bug. We will be on top of it just like that if you find a way to segfault Python without intentionally shooting yourself in the foot. There are ways to, if you set out to segfault, if you aim the gun at your toe, pull the hammer back and say, I wish my toe to be blown off, it is possible. But we do have safeties on that doesn't happen accidentally. Python, it is not the norm. And then lastly, behind the scenes, I think it's important that we have a benevolent dictator, somebody to resolve design conflicts and whatnot, so that in the end, you are using, this is Guido's language, and he just happens to let you be using it, and that gives it a certain uniformity of design. And one of our other winning characteristics is having agreed on some protocols, so that when someone makes some wrappers around on various databases, someone says, I wrap MySQL. Another one says, I wrap Postgres. Would they have wrapped it in the same way? The answer is yes, because we defined a DB API specification so that you can write a Python program that accesses those databases, later change your mind about the database, and not have to change any of your code. You might have to change the SQL statements because they have different flavors of SQL, but the Python part of it is the same. Same thing for hashlib. We have the same interface for SHA-1 as we do for MD5. Compression. The compress and decompress words are the same regardless of whether you're using XZ, GZ, BZIP2, or ZLib. WSGI, the one ring to bind them all. At one time we had many, 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 many web servers. Why? Because they're pretty darn easy to write. And at one time we had many, 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 many web frameworks. And they were easy to write. And some of them been matched where this group ran on this group and this group ran together on this group. And so the moment you chose one side, you were very limited on your choices of the other. Philip Eby put together a massive social effort. It wasn't just a technical effort, it was a social effort to find what was in common between all of those things. Call the people who made them, talk to them one at a time and say, can you add on to, don't continue to support your current users, but add on this extra interface that I call WSGI. He laid out a spec, and it's the one ring to bind them all, and now you can choose any framework with any web server and vice versa. That's fantastic. And file API. Well, the API doesn't seem that magical. Open, read, write, read line. How magic is that? Oh, well, we can use that same API for strings, and you get cstring.io. Or we can open a URL, and the same words open. These protocols unify the language and make it fairly easy to learn. If you learn the dumps and loads protocol for Pickle, guess what? You already know how to do JSON, and already know how to do Marshall. Who thinks that's fantastic? All right, so I've described the characteristics of a successful language, but I haven't given you any specifics of what makes Python different. And I have, in theory, 10 minutes left? Yep. I just borrowed 5. And he's like, I knew it was 5, but I said 10, and he folded. All right, so these are the high-level characteristics of the language. It's easy to learn. We have a rapid development cycle. Economy of expression is beautiful. One way to do it, interactive prompt, include the batteries. Lots of good stuff going on behind the scenes and common protocols. If you're going to build your new language X, it should do all of these things to be successful. But let's look at what we've got in the language itself, because I've not mentioned one line of Python yet of saying this is something Python can do that other languages don't. Here's what we got. Good solid foundation using dictionaries and lists. Why isn't sets on the list? Because you can do everything with just dicts and list. I've offered in the collections module many other collections that you can use that are specialized, but if I can teach somebody dicts and lists, they can create data structures of arbitrary complexity. Those two are sufficient to solve any problem. We have automatic memory management. That's fantastic. Those of you who have ever suffered with pointer leaks and writing to previously freed memory and whatnot know how much pain is involved and how much is saved. For those of you who just learned Python as your first language, you probably have no appreciation for how much pain other people live with. We have exceptions. We've made everything first class, which is fantastic. I highly recommend reading Joel on software. So Joel Spolsky has a lot of good advice, but he had this one article that was wonderful. It was called, "Can Your Language Do This?" And essentially the article was about first-class functions and first-class classes and the ability to pass them around as arguments. And he argues heavily in that paper that it enables you to have higher-level solutions to problems. It enables you to think thoughts that are not possible in languages where these things aren't first-class. And he said, basically, if you don't have if your language can't do this, you're using the wrong language, and you have taken the range of possible solution to problems and thrown a huge chunk of them away. And then we have overridable syntax, which is now fairly common in many languages. Everybody can override their add operator, although not everybody can override their dot. I have a whole talk on who owns the dot. Do you guys know the answer to that question? Who owns the dot?
I do.
Matter of fact, you do. Everybody knows they own the brackets. You know, in the first couple days of programming Python, you learn there's a magic method, under, get item, under. You're like, I can reprogram the brackets. And people happily reprogram the brackets for years, never realizing they can reprogram the dot too. You control what the dot does. You own the dot. All right. The Iterator protocol is something fantastic. It's the high-level glue that holds the language together. What's interesting when I talk to companies where they're big Java shops, they say, we've got iterators too. And so is C++. In fact, I can write an iterator protocol in every language. Why is it special in Python? It's special in Python because we've made an effort to make everything that could possibly be iterated follow the iterator protocol. We've also made everything that could possibly consume an iterator use the iterator protocol. And that way, you can take a string and feed it to set and feed that to sorted. And what will that do? That will uniquify the string, eliminate the duplicate elements, and then sort them. Which is interesting because sort was written before sets. It didn't know that sets existed. Sets were written without knowing anything about strings, yet these things fit together like Legos. So I like to use the Lego analogy of you reach into a box of Legos, you can take any two pieces, and they have these little dots on them that are the same size, and you push them together, and the Legos fit together. Now imagine a Lego box where they had 4 or 5 different connect sizes, and you grab two pieces, and they didn't just fit together neatly. How much less useful and less fun would Legos be? Python has the Lego design. Our iterators are the glue that fit the language together. And if you expand your mind a little bit, you can see a relationship between how we use iterators and how pipes and filters are used in Unix. It's a winning language feature. List comprehensions are by far one of the most popular features of the language. When I teach people list comprehensions, they experience joy. Has that been your experience, Peter? All right, they're clean and beautiful. They're derived from a notation used in mathematics. They're much more expressive and flexible than map, filter, and reduce, the traditional functional programming operators. All right, here's something we got nobody else ain't got. That's generators. Generators have magical properties. They're running along, and then suddenly they stop. They remember where they were. They remember if they're in the middle of the loop. They remember any pending try excepts. They know where they are in a success of calls and a stack, and they yield back up. And later when you call next on them, they pick up where they left off, remembering all the local variables and resuming, enabling us to do powerful coroutine style programming. There's a lot of wonderful things that can be done with generators. They can be done also with classes, but it's very hard with classes. We've taken problems that are really hard that take advanced programmers in other languages, things that you need a hardcore C++ programmer to do. Junior Python programmers can do easily with generators. We bang things out in generators in seconds that take people days in other languages. I think it's fantastic. Okay, another winning feature was we combined these great ideas. We took generators, and those were great. List comprehensions were great. How about we marry the two and see what the offspring looks like? And we get generator expressions, say, comprehensions and disk comps. Who likes those? They're fantastic. Who knows what's special about generator expressions? Oh,
Yeah, they're easy, lazy.
yeah. Okay, so when I teach a class, I always like to say, I'm going to give you a pop quiz periodically, and I'm going to ask you the question, what is special about this feature? And the answer is always the same. I made that. That's a Raymond. Okay, and Decorators, they're fantastic. They're easy on the eyes. They're expressive. We had no idea how great they were going to be. There's this Django project that said it needed them. There was another project that said it would have been nice to have. And our thought was, well, you could just, it doesn't really do much. It's just a little syntactic sugar. My goodness, it transformed the language. They're incredibly expressive, and it adds a powerful layer of composable tools. If I had time, I would show you the Fibonacci example where I take an incredibly slow program and I make it fast just by adding one line, at LRU cache. What does that do for us? It takes a traditionally written program algorithm and it makes it into a dynamic algorithm. And it's fantastic. So that'll be a talk for another day. The important thing is amazing things can be done just by adding decorators in front of functions and classes. Another winning feature, something that you don't get with compiled language, is the ability to introspect itself. One of the things I like to show off to people when I'm teaching them Python is the help function. I said, help collections module. How does it, and they're not impressed. I said, how does this work in any other language? How does it work if you type man and the name of some function in Unix? It goes out and it looks up a pre-made text file and it shows you that. Not very impressive. What does it do in Python? It builds it on the fly. It introspects the code and generates it. This is not a pre-made help file. And then we have the ability to exec and eval. These have tended to fall into disuse, but they are amazingly powerful tools, and I recommend putting them back into your toolbox. Lisp users will tell you that's the thing that makes Lisp Lisp, is the ability to evaluate itself. And a language that can evaluate itself has an extra layer of capabilities that you won't find almost anywhere else. Go take a look at the source code for time it, or take a look at the source code for name tuple. You'll see a couple excellent uses of exec and eval. They are not sinful. And then the with statement is new technology. It's wonderful. So, in the old days, they had go-tos. And then they had this idea. They said, you know what, we are using the same piece of code over and over again, and thus was born GoSub. 50 years ago, we got the subroutine. How important was that for the advancement of man? Hugely important. GoSub to a subroutine and use the same piece of code over and over again. Where does it come up? I have a programming pattern. Code A, B, followed by C. Later, I have a piece of code where the part in the middle is the same as it was the first time. I take that, factor out the code in the middle, and I do a GoSub to it. I make a subroutine out of it. It's fantastic. So the middle of the sandwich is the part that's the same. We have lots of ways to take tuna and put different kinds of bread around it. That was the subroutine. The with statement does the opposite. The with statement says, what if the setup code and the teardown code are the acquire lock and the release lock? What if that's the part that's the same and the part that's inside the sandwich changed? So now suddenly I have several different types. I say, I'm going to have something on rye, and I can put inside tuna and various types of meat and whatnot. It is the inverse of the complement to the subroutine, and I contend that the with statement is as important as the invention of the subroutine. It's going to be that useful. And it's new enough to where you probably haven't deeply stuck it into your thinking, but context managers and the with statement are a major advance in computer science technology. You will start to see it in other languages in the next few years. We got it first. And we have abstract base classes. Well, lots of languages have abstract base classes. Ours have mix-ins. How long does it take you to write a dictionary-like object? Well, you just write a class that defines get item, set item, delete item, and iter, and then inherit from the abstract base class, and you get all the other methods for free. Who thinks that's fantastic? All right. And our winning feature is the indentation. It contributes to the clean, uncluttered appearance. Richard gave a fantastic example of code in C that could cause tremendous headaches because the indentation didn't match. I usually tell a story here of a piece of code that took AT&T offline for 8 hours. In the end, they traced it down to an indentation error where the indentation suggested that the code did something different from what it actually did. That type of error is not possible in Python. The appearance of the program doesn't lie to you about what it does. If something is indented under the for loop, it's in the body of the for loop. If it's not indented, it's not. The appearance matches the functionality. That's important. All right, so the summary is we have a solid foundation. We built on top of the Dict and licks. We have automatic memory management, exceptions, first-class features, overridable syntax. We've glued the language together with the Lego, the uniform, the Iterator protocol. We have generators. Nobody else got those except for Icon. We married the two together, made Genexps. We have beautiful decorators. We can introspect. We have abstract base classes with mix-ins and the ability to exec ourselves. And we have the new with statement, the new technology, and beautiful indentation. I contend that Python is awesome. Do you agree?
Yes.
Fantastic. Thank you for inviting me here.